Good morning everyone. Myself Megha Rathod. I am teaching maths in LPSAVANI VIDHYABHAVAN. In last session we have completed the discussion of axiom, postulates and introduction of chapter number 5. Now we start exercise 5.1. So take out maths textbook and read the question from the textbook. Here the first question is, which of the following statement are true and which are false? Give reason for your answer. So now we discuss about these statements with reason. So here first statement you can see here, only one line can pass through point. This is our statement. Answer is, this statement is false because from a single point an infinite number of lines can pass. Now statement number 2, there are an infinite number of lines which pass through two distinct points. This statement is false because by axiom given two distinct points, there is a unique line that passes through them which contradicts the given statement. Now statement number 3, a terminated line can be produced infinitely on both the sides. This statement is true by Euclid's second postulate. Now fourth, if two circles are equal, then their radius are equal. The statement is true by Euclid's fifth axiom. Now last statement, in the figure given below, if AB is equal to PQ, then PQ is equal to XY, then AB is equal to XY. Here AB, PQ and XY, this is given the figure and this statement is true by Euclid's first axiom. Now we start question number 2. Give a definition for each of the following terms. Are there other terms that need to be defined first? What are they and how might you define them? Here give you 5 terms and we discuss about it. First is parallel lines. Two lines which have no common points are called parallel lines. In figure you see L and M are parallel lines because they have no common points, and write them L parallel M. Here the terms point and line are undefined. Now second is a perpendicular lines. Two lines in a same plane which intersect each other at right angle are called perpendicular lines. You see in the figure M and N lines intersects at 90 degree. In figure M and N lines intersect at 90 degrees, so they are perpendicular lines, and write them M perpendicular N. Here the terms angle is undefined. Now third, line segment. The definite length between two points is called the line segment. It has two end points. You see the figure AB is a line segment. In figure AB is a line segment and it has written as AB line segment. Here the terms point and definite length are undefined. Now fourth one is radius of a circle. The distance from the center of a point, center to a point on the circle is called the radius of the circle. You see here, this is a circle. O is the center of the circle, and P is on the point on the circle. So OP is a radius. In the given figure, OP is the radius of the circle. Here the terms center and point are undefined. Now fifth is square, a quadrilateral in which all four angles are right angles and all the four sides are equal is called a square. If you see here, A, B, C, D is a square. AB is equal to BC is equal to CD is equal to AD, and angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90. Now we start question number 3. Consider two postulates given below. Given any two distinct points A and B, there exists a third point C which is in between A and B. Second is, there exist at least 3 points. They are not on the same line. Now, do this postulate contain any undefined terms? Are these postulate consistent? Do they follow from Euclid's postulate? Explain. Now we discuss about the answer. Here answer number 3. Yes, these postulates contains so many undefined terms which should be listed. Also, they are consistent because they deal with two different situations which are as follows. First, given 2 points A and B, there is a point C lying on the same line in between them. Now second number is if 2 points A and B are given, we can take C not lying on the line through A and B. Here, thus, these points do not contradict each other. These postulates do not follow Euclid's postulates. However, they follow the axioms. Given two distinct points, this is a unique line that passes through them. Now we start question number 4. If a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to 1 half AB. Explain by drawing the figure. First, here we draw the figure. Here is a AB line and C is in middle. So here give you AC is equal to BC is given. Add AC both sides. Now AC plus AC is equal to AC plus BC. Equal are added to equal. This is the axiom. Here 2AC is equal to AB because AC plus BC is equal to AB. Now you can see that here AC is equal to 1 half AB. Now start question number 5. In question number 4, point C is called a midpoint of line segment AB. Prove that if every line segment has one and only one midpoint. Now, let there be two midpoints C and D of line segment AB. You see in the figure AAB line segments, let C and D a midpoint. If C is a midpoint, AC is equal to 1 half AB. This is number 1. If D is a midpoint, the AD is equal to 1 half AB. AB is equal to number 2. From equation 1 and 2, you can see that AC is equal to AD by axiom 1. So, you can see that which is possible only when C and D coincide. So, point D lies on C. Hence, every line segment has on one and only one midpoint. In question number 6, in figure, if AC is equal to BD, then prove that AB is equal to CD. You can see the figure A, B, C, and D. So, here AC is equal to BD, this is the one is given. From the figure, we can write that AC is equal to AB plus BC, number 2, and BD is equal to CD plus BC, this is number 3. Now, put the values from equation 2 and 3 in equation 1. Here we put the value, then we can write AB plus BC is equal to CD plus BC. Now, by axiom 3, if equals are subtracted from equals, the remainders are equal. So, AB is equal to CD. Now, question number 7. Why is axioms in the list of Euclid's axioms considered a universal truth? According to axiom 5, we have the whole is greater than the part. This statement is true for anything in any part of the universe. So, it is a universal truth. Here we completed the exercise 5.1 and not now. Write all examples in your fair book from the textbook. Now take out maths textbook, page number 86. We discuss about equivalent versions of Euclid's fifth postulate. Euclid's fifth postulate is very significant in the history of mathematicians. There are several equivalent versions of these postulates. One of them is Playfair's axiom, given by a Scottish mathematician John Playfair in 1729, and stated it below. This is the Playfair's axiom. You have to learn this axiom properly because so many times asked in the question paper. For every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. Here in figure 5.11, you can see that of all the lines passing through the point P, only line M is parallel to line L. This result can also be stated in the following form. Two distinct intersecting lines cannot be parallel to same line. You underline these lines in your textbook also and learn this properly. Now we start exercise 5.2. I read the question. If you can't understand the question from this, you can take out the maths textbook and read the question from them. How would you rewrite axiom's fifth postulate so that it would be easier to understand? Answer. Two distinct intersecting lines cannot be parallel to the same line. This is a simple language for the fifth postulate. Now question number 2. Does Euclid's fifth postulate imply the existence of parallel lines? Explain. Here given the figure. Yes, if a straight line L falls on two straight lines M and N such that the sum of the interior angles on one side L is two right angles, then by Euclid's fifth postulate, the lines will not meet on that side of L. Also, we know that the sum of the interior angles on the other side of line L will be also be two right angles, so they will not meet on the other side also. Here M and N never meet, and second is M and N are parallel. Here we complete our exercise 5.2, and now our chapter number 5 is completed. So it is compulsory to write all exercise sums and all examples in your fair book, and important notes also you have to write in your fair book. And I will give you one assignment. This assignment you have to write yourself in your fair book also. Now we start in next session chapter number 15.